In this video, I will be showing you how to take your raw data and computing what you need to have for your formal data table and eventually your graph for the experiment where we varied the system mass and saw how that affected the acceleration of the system for a given amount of net unbalanced force exerted on the system. So in a previous video, we collected these data points, and now we're going to take the data we have and convert it into the data we want, doing some calculations. Anytime you're doing math, anytime you're grabbing your calculator here, you should be making a formal data table. So, right, raw data is what you directly measured. Form a data table is the calculations you did to get the desired relationship. In this case, we're already pretty good. This is the desired relationship. The difference is, the only thing we really need to do is take this mass in grams and turn it into the SI units of kilograms. And the other thing we'll need to do is the control variable really is the force exerted on the system. So we'll need to take the hanger mass, which we measured, and convert that into the net force exerted on the system. So those are our goals. Every time we do a calculated column in a formal data table, we need to show a sample calculation for one of those data points, but then you don't need to show it for the rest. So let's start by coming up with the system mass in kilograms. Over in our sample calculations, I'm going to start by stating the calculation. And the calculation I'm doing is system mass from grams to kilograms. And the way this calculation works is that you start with 276.1 grams, grabbing the number right out of the data table here, and then you multiply by a conversion factor. The conversion factor we're going to multiply by is the one that has kilograms in the numerator and grams in the denominator. And the reason for that is we want the grams to cancel. I want to be left with kilograms in the end. So now we say in 1 kilogram, there are 1,000 grams. And so the calculation we need to do is 276.1 multiplied by 1 over 1,000. I'm going to grab my calculator. I'm going to say 276.1 multiplied by 1 over 1,000 is 0.2761 kilograms. Of course, the other way to do this is take your 276.1 and divide by 1,000, or just take 276.1 and move the decimal to the left 3 places. So there we go. I can now, in my system mass, I had 276.1. Over here, I have 0.2761 kilograms. That's my calculation. Now that I've done it for one data point, I'll need to do that calculation for the rest of my data points, but I don't need to show my work. And so 526.1, go to a calculator, 526.1, divide by 1,000. I am left with 0.5261 kilograms of mass. I only have 2 data points shown. You will do it for all of your data points. The acceleration is already in SI units, and so I can just copy those numbers down. 1.922 meters per second each second, and 1.032 meters per second each second. And again, you'll do that for all of your acceleration values. You should have at least 5 for this experiment, and then at most 7. Last but not least, our control variable is the net force down here at the bottom. And so we need to take the hanger mass, convert it into a net force. Here's where more sample calculations are going to come in. We're going to compute the net force exerted on the system. In this case, the net force on our system is equal to the gravitational force exerted on the hanger by the Earth. And then we take that vector equation, make it a scalar equation, assuming the direction of the gravity force is our positive direction. So there we go, there's our net force. And we also know that we can compute the gravitational force on the hanger by the Earth by taking the hanger's mass and multiplying by the Earth's gravitational field strength. And so if we put those two calculations together, what we are left with is the net force exerted on the system must be equal to the hanger mass multiplied by the Earth's gravitational field strength. Now we're set to plug in numbers. The net force exerted on the system is the hangar's mass, which for my example was 55 grams. 55 grams, I've got to convert that to kilograms. That's 55 divided by 1,000 is 0.55 kilograms, or 0.055 kilograms. Do I need to show that work? No, I do not, because I have a conversion from grams to kilograms already shown in my sample calculations. So 0.055 kilograms is the mass, multiplied by the Earth's gravitational field strength of 9.81 newtons per kilogram. So I'll take 0.055 multiplied by 9.81. And what I'm left with is the net force exerted on the system is 0.5. How many sig figs do I want to round to? I've got, I don't know, 2 of them here. So 2, I think, here. 0.54 newtons. And I go and look at my units, kilograms in the numerator, cancel the kilograms in the denominator, and I am left with newtons of force. So that works out. And I can now take this 0.54 newtons and add it to my formal data table. The net force, the control variable there, 0.54 newtons of force were exerted on my system. And now we're set. We want to plot acceleration, which is this column, versus the system mass in units of kilograms, which is this column. Now again, I want you to think about this language, acceleration versus net force. That means what goes on our x-axis, what goes on our y-axis to show our relationship. So this video walks you through how to do the sample calculations needed to lead to the formal data table to show the relationship we want to show in the experiment where we varied the system mass and looked at the effect on the acceleration while keeping the hangar mass constant.